What up guys, my name is Emmanuel. Welcome to my 10th video. Today we're going to learn about classes. Create a new project and let's get started. We could think of classes as a template or a blueprint that we want instances of a class to conform to. To create a class is actually very easy. We use the keyword class, followed by the class name. We could use user as an example. Now within a class we have properties, we have methods. And properties are simply like our regular variables, while methods are like our regular functions. So to create a property called name, we just say let name be of type string, right? We could also create another property called email, and it could be of type string as well. Now we have two methods that are available in a class. We have the initializer and the deinitializer. The initializer is called whenever an instance of a class is created, while a deinitializer is called when an instance of a class is destroyed. So to do that, we just say init, and within our parameters, we pass in the data that we want to initialize in our class. So I want to initialize name of type string. What am I typing today? So name of type string and also email of type string. Okay? Now, within our initializer block, I want to set the values of our properties. So say self.name should be equal to our name. Self.email should be equal to our email. Simple enough. Now, to show you that this method is actually going to be created, let's just have a print statement here and say an instance was created. Okay? Now we're going to have our deinitializer here, and we're simply going to print out an instance has been destroyed. Okay? Great. Now, whenever we want to create an instance of a class, I'm sure you recognize that you've seen this before, is we just say let, and we can call this user1 be equal to user, right? So when we open our parentheses here, we're going to see the properties that are available within this class. So we have name, and we could just say Emmanuel, email, emma@just.com. Okay? Now, this here is an instance of a class. We could actually create different other instances, which are like separate worlds of their own. So user2 equals user, and this is going to have its own data. So say uzo, and this is going to be uzo@test.com. Okay? Now, let's actually run this, and we expect to see this and this printed out twice. Okay, for the sake of identifying what object exactly, we're going to print out the name here, and we're going to do the same thing right here so that we can know what user's object exactly is being created or destroyed. So we're going to run this, and right here, I'm sure you can see this, an instance was created Emmanuel, an instance was created Uzo. Now they've actually not been destroyed, so let's try deinitializing them by setting their values to nil. So user1 is going to be equal to nil, and user2 is going to be equal to nil. Well, let's deinitialize 2 first, just so you know, can prove that it works. And of course, yeah, we cannot assign a value to a let, which is a constant. So we need to change this to a variable, this as well to a variable. Then also we need to specify that this is optional since we're going to be assigning nil. So to do that, we're going to say that this is of type user as an optional. Same here, user as optional. Now this way we can actually assign nil to our instances of the user class, and this should return what we expect. Let's see that. Awesome. So an instance was created Emmanuel, an instance was created Uzo, an instance has been destroyed Uzo, and then Emmanuel, which is what we did here. So user 2, then user 1. Great. Now, something else worth mentioning is that we could actually protect data in our classes. So let's say I do not want our name to be accessible outside the class. So take this as an example. I could actually print the name of the first user outside here. So let's print the email. So we just say user1 dot email. So you can see that we actually have access to the property of the class from outside of the class. So this is going to be is email, and we could actually have access to the other instances email as well. We could just say second email. I'm bad with naming. So now can you actually guess what the problem is? Well, if you remember from our videos about optionals, this is an optional. So we have to unwrap this. So we're using optional chaining here. Now, if we run this, we are going to get something is an email, of course, Emma test and Uzo test. Great. Now, what if I want these variables to only be accessible within the class? We could actually just do something like this. Private. Uh-oh. What? 2 times. So private. Now, when we do this, we're going to see that name is not going to be accessible from outside of the class. So you can see that name is no longer an option. So right name is going to say name is not an instance, whatever. So name is inaccessible due to private protection level. Isn't that cool? Great. Now, in order for me to actually get access to the value of this property, we could actually create a public method within the class. So you could do something like this, func get name, and this is going to return a string. And here what we're going to do is we're going to say return name or self.name, right? They're actually the same thing. Self means self is referencing the class. So now here we're going to say get name like that, because get name is a public function and this has access to the private property within the class. Like I said, this is only available within the class. So when we run this, we are going to get Emmanuel is email. Correct. Okay? We can actually do a lot more, but I'm just going to end this video by explaining the difference between a class and a structure. Now, to do this, let's use an example. Now, as you've seen here, we've actually created an instance of this class called user1 and another instance of the class called user2. Okay? Now, one major difference between a class and a struct is a class is a reference type, while a struct is a value type. What that simply means is that whenever you create a new variable from an existing instance, what it does is it gives an instance rather than a copy. So now that we have a variable that's an instance of this class, if I actually assign user to like a different variable, let's say different diff equals user1. Whenever I make changes to this variable, it actually affects the original. So here, let's just say diff dot email, since that's what we have access to, and we're just gonna say changed at test.com. Okay, and now let's actually print. Okay, we're already printing out the email of user2. So we're just going to change this to user2. And of course, email is a let, it's a constant, so we need to change that to a variable as well. And that should be fine. Okay, yes, we have to unwrap this because user2 is an optional. So now let's run this and we should get what we expect again. Wow, I'm on fire today. So changed at test.com is second email. Now notice we didn't actually print the email of the diff, which was what we assigned. Sorry, we didn't print the email of diff. We printed the email of user2, which we actually did not directly change. Okay, but the change actually affected this instance. So that's what I meant. Whenever you assign an instance to a new variable, it actually creates a reference to memory, to just one location. But for a struct, this is not going to change, this right here is not going to change the value of this particular variable. Let's try that and see. So we are going to, let's just, make some room here. So we're going to create a struct of type user struct. This is going to take name as string. I'm just going to keep this short for the sake of video. I don't want it to get too long. So here, let's create an instance of the struct. So let's user s1 equals user struct, and this is going to take name as Emmanuel. Okay, now let's actually assign this to a new variable. So we're going to say let diff2 equals user s1, right? Now let's change the value of diff2, and I'm sure you've seen this again. I need to make that a variable. So diff2 dot name equals changed name, right? So yeah, of course, so here change to a variable. Now let's try printing it. So this is a struct, and the name diff2 dot name is going to have a value, and let's just copy this and actually print for our user s1. Or I need to learn how to write good names. So I'm just going to say this as user s1, say this as diff2. This is original. This is copy. Just so that you can see that it's actually different. So we're going to run this. And what are they saying here? Yup, this has to be a var as well, because I'm making changes to the copy. So we're going to run this, and here we have, this is original Emmanuel, this is copy change name. So you can see that, what error am I having again? diff2, thought I changed that already. Xcode. Oh well, this did not change the value of the original reference, but from our class example, it actually changed the original value. I hope I was able to convince you. I almost said confuse. Anyways, if you have any questions, please leave it in the comment section. I'll gladly answer. And if you enjoyed the video, please like and don't forget to subscribe. See you guys in the next video.